Next example is this. Example, this is number 2, example 2. Same instructions, divide. And what I want you to divide is 2a cubed plus a minus 3 all over a plus 2. Ooh, in this one we'll have to use step 2, and I'll explain what that means. This as a cubed term. The next term should be a squared term, but we don't have one. And then there's a regular a term and then a constant. So it is in descending order, but it doesn't have placeholders. We want every term in between to be there. We want an a squared term. So we're going to put it in there by going like this. 2a cubed plus 0a squared. That's the 0 placeholder. 0. It's holding its place right there behind the whatever. Plus a minus 3 all over, and this is fine. It has a to the 1 and then a constant, so we don't need to put any placeholders there. A plus 2. So step 1, arrange terms in ascending order, descending order. That was done. Input placeholders, that's what we just did. And step 3 is in and out. So we can just do that right now. 0a squared plus a minus 3. And you'll see why this is important. Or if not, I'll just tell you why it's important. Because it gets confusing if you don't put it in. And I'll show you. So if we're dividing, we're looking at the first terms here. What times a will give me 2a cubed? Well, I need a 2. 2 times a, that'll give me 2a. So how do I get an a cubed? Multiply by a squared. That'll give me 2a cubed. Remember, I'm multiplying this whole thing by this whole thing, or this by this whole thing. So I have plus 4a squared, because it's 2a squared times a to give me this. 2a squared times positive 2 to give me that. And then I subtract. So I'm going to change the signs. And I'm changing them because I'm subtracting, not because I'm just doing whatever I want. Oh, I'm going to change the sign, yeah! No, no! And then I'm subtracting. So these go away. And then here, see, I'm subtracting correct. I'm subtracting like terms. That's why I need a placeholder. Otherwise, I might have done 1 minus 4, and that's not right, because these aren't like terms. These are. So I'm left with minus 4a squared, and then I bring down everything else, and then I start all over again with my division. So what times a will give me negative 4a squared? Well, I need a negative 4, that's for sure. What times a will give me a squared? Just an a. So negative 4a times a is negative 4a squared, and then negative 4a times 2 is negative 8a, and I'm subtracting. So I'm going to change that sign, because I'm subtracting, not because I do whatever I want. So those go away, and then these are like terms, good. And that's 9a minus 3. And then one more time. What times a will give me 9a? 9. So plus 9, it's got to be positive. That gives me 9 times a is 9a. 9 times 2, positive 2 is positive 18. Subtract again. And that means changing the sign. So these go away. And this is, I think, negative 21. So in this example, we ended up with 0. So we can just write down our answer. Next example, I have nothing more to bring down, so I can't do anything else, except for I still have a remainder. And this remainder I will write like this. So our answer here is this stuff. So 2a squared minus 4a plus 9. And then I add this on, minus 21 over a plus 2. A plus 2. And yeah, that 21 came from there. So that is my answer when I have a remainder. This a plus 2 came from right over here, because it was just like when we did division with the regular numbers. 62 and 5 over 14, whatever we're dividing by. And is the same thing as plus, and we're adding a negative, so it's subtract 21 over whatever we're dividing by. And that's it. So this is one with a remainder. And it's really just division, except for you have letters and stuff. So one more example. I think I wanted to add a note. Oh. Don't forget to add 0 placeholders. That's my note. Forget to input 0 placeholders. If you forget, then you might end up subtracting terms that aren't like terms, so that'd be wrong. Okay, last example. Another piece of advice for these is be patient, go slow, be careful, because you'll mess up. I messed up. Look at this. I messed up. All of this. It was all... I messed up. So I gotta start over. So just go slow and you'll be fine. Example. Last example. This will be example 3. And the instructions are to divide. Again, this is a long one. 2x to the 4th minus x cubed times y plus x squared y squared plus 4xy cubed minus 4y to the 4th. Oh. Whew. Divided by 2x squared plus xy minus 2y squared. What's different about this one? It has 2 variables in it, an x and a y. So, my roommate's taking a shower. So, there's something different that we have to do for this. And I'm going to tell you what it is. This is my note for this one. Write your polynomials. Write polynomials. With the main variable, in this case x, because I'm used to x and we're dividing with x's for x's. So write the main variable at the end of each term. And that will be in blue. So, what I mean by this is in each one of these terms, the x should be the thing that comes last, and it just makes it easier throughout the rest of the problem. So that's what I'm going to do first, is rewrite this. So 2x to the 4th, my x term is coming after my constant or coefficient. My x term here is in front, so I'm going to say minus y times x cubed plus y squared, I'm switching these, times x squared plus 4y cubed x minus 4y to the 4th. It also helps me to see that it is in descending order because the x terms are last, and I can just look at the end of each term. Here there's just no x term. It's up here I might get confused, like this one's cubed and this one, oh, it's squared, but it's the y, and I'm not looking at the y, I'm looking at the x value. So just rewrite them with the x term coming last. Or, I mean the main variable coming at the end of each term. Say, plus yx minus 2y squared. And then we can go on with our normal steps. So in and out, 2x to the fourth minus yx cubed plus y squared x squared plus 4y cubed x minus 4y to the fourth. Jeez. Plus yx minus 2y squared. 2x squared plus 2yx minus y squared. And now I'm ready to go. And I'm looking at the first terms. What times 2x squared gives me this? Just x squared. And I multiply it out. So I have 2x to the fourth. And then plus yx to the third. And minus 2y squared x squared. I'm subtracting, so I'm going to change all of these signs. And I'm always going to highlight them just so that you guys don't get confused. Why is he changing the sign all of a sudden? It's because I'm subtracting. So these go away. These are both negative, so it's just negative 2yx cubed. These are both positive, so we add them. Plus 3y squared x squared. And they're like terms. I forgot to look for it, but I already knew because I did this before. Always look to add in zero placeholders when you guys are doing it. So that's that, and then I bring everything else down. So plus 4y cubed x minus 4y to the fourth. And then now I'm looking at the first term again. What times 2x squared will give me negative 2y cubed? Negative, first of all. I already have that 2. I need a y. So negative y, and then I need one more x times x. So this will give me negative 2y x cubed, right? Then I have negative y squared x squared. And then I have negative positive 2y cubed x. And that's it. I don't have enough for that term. I'm going to change the sign, but that's because I'm subtracting. That's what you have to do every time. These go away because they're opposites. These are the same, so it's just 4y squared x squared, and this is positive 2y cubed x. Am I going too far down? y cubed x, and then bring down that 4y to the fourth. The next one, something beautiful happens. I'm so happy that it happens. So, I'm looking at the first terms again. What times 2x squared will give me this? And it's a positive 2y squared. That'll do it. 2 times 2 is 4y squared, and then times that x squared. Yes! And then 2, that's 2y squared x. And that's plus. And then this is minus 4y to the fourth. Oh, look at that. It's the same. I have to change the signs because I'm subtracting. Ooh. And look what happens. Bam, bam. Bam, bam. Whoosh. 0. Nothing is left. No remainder. So, my answer is just what's up top here, because it divides evenly, because I get a 0 remainder. X squared minus y x plus 2y squared. Division of polynomials. That is all. Booyah! Do people say that anymore? I do.